Hello, my name is Elise Huang, and I'm a junior at La Cañada High School in La Cañada. My project investigated the interactions and structures of GUN4 and SRP43. So just for some general background, chaperone proteins assist in protein folding and often prevent aggregation. And this project studies the interactions between signal recognition particle 43, or SRP43, a chaperone protein in plants, and its client, genomes uncoupled 4, or GUN4, a key chlorophyll synthesis protein. SRP43 chaperones GUN4 at high temperatures to prevent aggregation due to heat denaturation. FRET, or forced resonance energy transfer, assays measure close interactions between two proteins labeled with fluorescent dyes. When the two dyes are very close, FRET occurs and fluorescence decreases. So when fluorescence decreases, SRP43 is chaperoning GUN4 because the two proteins are both labeled with dyes. Chaperone proteins often chaperone a wide range of denatured client protein forms, and the goal of this project was to characterize the forms of GUN4 that SRP43 chaperones using FRET along with the chemical denaturants urea and guanidine and circular dichrose and melts. The hypotheses of this experiment were that if GUN4 is chemically denatured, then SRP43 will chaperone GUN4 and FRET will occur. And if SRP43 chaperones GUN4, then GUN4 will be chaperoned in a partially unfolded state. In terms of procedures, firstly, a urea titration was performed on a solution of fluorescent dye labeled SRP43 and labeled GUN4, and fluorescence differences were measured using a fluorometer to determine if the two dyes came close. Secondly, the fluorescence differences between interactions between labeled GUN4 and labeled and unlabeled SRP43 under increasing guanidine concentrations were measured. Lastly, a circular dichrose and melt was performed on SRP43, GUN4, and SRP43 and GUN4 together. For the urea titration compared with fluorescence, there is a slight decrease, then increase in fluorescence as urea is titrated in. However, the results of this assay cannot be properly interpreted because urea is found to increase buffer fluorescence, meaning two independent variables are simultaneously affecting fluorescence, urea concentration and FRET due to chaperoning activity. This guanidine spectra from the second experiment shows that there is a 5 to 8% decrease at 470 nanometers between the control groups, represented by the solid lines with unlabeled 43, in which FRET does not occur, and the groups with labeled 43, represented by the dotted lines, in which FRET should occur. This means that SRP43 chaperones a small amount of GUN4. However, previous experiments with heat show that as it denatured becomes more intense, percent change in fluorescence actually should become larger rather than staying consistent as it does in this experiment, as you can see here. This discrepancy suggests chemical denaturation does not directly induce chaperone activity in SRP43. Circular dichrosum, or CD, measures secondary structure, and a lower molar ellipticity at this wavelength suggests increased protein structure, which correlates with how folded a protein is. In this graph, the blue curve represents unchaperoned GUN4, subject to a temperature melt. Up until around 36 degrees Celsius, GUN4's secondary structure remains stable. However, after 36 degrees Celsius, its structure begins to denature or melt until it becomes its totally unfolded form. The green curve represents the secondary structure of chaperoned GUN4. Even before unchaperoned GUN4 begins to melt, 43 causes GUN4 to partially misfold, as the molar ellipticity of chaperoned GUN4 is higher than that of unchaperoned GUN4 below 36 degrees Celsius. Nevertheless, SRP43 chaperones GUN4 and thus maintains this partially folded GUN4 form past the melting point of 36 degrees of unchaperoned GUN4. As you can see, the molar ellipticity of the chaperoned GUN4 is actually lower than that of the unchaperoned GUN4 after the unchaperoned GUN4 begins to melt, showing that SRP43 prevents a complete loss of secondary structure and misfolding. So in conclusion, hypothesis 1 is untrue. FRET assays show that when GUN4 is chemically denatured with guanidine, it is not chaperoned well by 43. SRP43 chaperones a specific misfolded form of GUN4 that is characteristically heat denatured. However, the second hypothesis is true. The circular dichrosum results show SRP43 chaperones GUN4 in a partially unfolded state, and SRP43 prevents GUN4 from unfolding at higher temperatures. Interestingly, chaperoned GUN4 partially loses secondary structure and misfolds even before heat would normally begin to denature GUN4, suggesting SRP43 chaperones GUN4 prior to GUN4 beginning to denature. The key takeaways of this project are that the chaperone-client interactions are driven by more specific and complex processes than hydrophobic interactions, and SRP43 chaperones GUN4 at lower temperatures, lower than its typical melting point, in fact. Potential future experiments include characterizing interactions between SRP43 and other chlorophyll synthesis proteins and examining structural differences between guanidine denatured GUN4 and heat denatured GUN4. Thank you.